Hi, I'm Mike Andrews. I'm the co-creator and co-founder of the Smart Competition. Also an electrical engineer by training and managing partner of a consulting firm that specializes in new product development, innovation, and business operations. Well, we're here today to talk about the Smart Competition and your students. So here are some of the topics that we're going to address during the conversation. The Smart Competition is not about IQ. It's about sustainable materials and renewable technology. That's sustainable materials and renewable technology, SMART. It's a global high school and now university STEM and CTE program. The competition provides a hands-on experience for the students that are involved. They get a chance to do things that relate to sustainability, environmentally friendly design, and intelligent buildings, along with doing some reality modeling and some really interesting computer graphics. When we created the program, we knew there were going to be three major challenges that are going to be faced by our next generation, the students that are in our classroom. Those three challenges were energy use, building efficiency, and energy production. Those are the big three that the students are going to have to address as they move into that next generation of designers. The SMART competition enables students to get very creative with building designs and energy creation, energy production, and environmentally friendly design principles. We believe that every student that you have wants to create something that changes the world, that makes an impact. They want to make a difference. They want to do something that improves the planet by using renewable energy sources, responsible renewable energy sources, such as water and solar and wind and so on. All of those technologies that are out there, they're going to improve upon. We also believe that the students want to increase and improve their understanding of what sustainable materials are. Sustainable materials are all around you. We use them as waste byproducts and so forth. Well, how can they recreate those waste materials into a sustainable product that can be used in buildings, bridges, roads, and so on? And last, they want to work with real tools, tools that other professionals use so that they can enable their own imagination, they can implement ideas and solutions and develop some real proposals that make a difference. So based on those challenges, what we've had to do with the SMART competition is we created a real world design challenge around a situation that the students all understood, a high school campus. We asked them to look at that high school campus as an opportunity to explore some environmentally friendly redesign. Because we're giving them a purposely designed, bad design building, and they're going to modify that building. They're going to test those design concepts that they're implementing and then measure those results. In other words, the tools that they're going to use are exactly what other engineers and architects use. They have to measure the results just like the professionals do. And there are 850,000 of these engineers and architects and engineering professionals that use the same tools around the world. The problem statement is very simple. Students are given a virtual model of a high school campus with a purposely bad designed gymnasium. Their task is using the Bentley software to conduct energy and loading analysis, improve the building, and they can improve the building by changing any materials. Okay, it's windows, walls, doors, floors, HVAC systems, lighting systems. They can change the building orientation. If they don't like it facing north, they can face it northeast if they want, or west. Doesn't make any difference. They have that full design capability. And they also can change the landscaping materials. That's all capable within the software. So if they can dream it, they can make it happen within the software. And then Also, using some renewable technologies, they're asked to add power generation capabilities to the campus. So that means that they can add water powered, they can add solar powered, they can add wind powered, they can do biomass things, they can use glycol-based buried lines as heat transfer systems. All of that becomes possible with a goal of not only providing power for their campus, but providing the surplus energy out to that community's smart grid. So the whole problem statement and the whole smart competition is a holistic view that drives for solutions. It's an earthbound building information systems based program that gives your students a real opportunity to be very, very creative. So we provide a series of resources for the students. Okay, the software that's being provided by Bentley Systems requires a real geographic location. So we searched the world over and found the ideal place that had enough real estate, was close to water, had a city not far from there, and all the other things that created the infrastructure for this school to exist. So we found a place in Nash County, North Carolina, and that's where our model school exists. Our virtual model of the school exists. Okay, and the second big resource that I've mentioned is provided by Bentley Systems. The software tools that engineering professionals all over the world use, the students have access to that software. You and the mentors have access to that software. And last but not least, we've created a series of education and learning modules that can be used by the teachers in the classroom. And it goes from, how is power basically generated? What is a dam, or what is a water-based system, or what does a solar system and battery system look like? Because a lot of students have never seen an overhead transmission line. They think that all their power comes from a socket at the wall. So we provide materials, educational materials for the teachers that they can use in the classroom to support their educational objectives. Additionally, Bentley Systems has opened their arms to the competition and to the students that are involved. You and the students and your mentors can be part of the Bentley community, which is a group of technical professionals and resources from all over the world. The Jumpstart program and the Get Connected program are directed at university and high school students. An important resource here is the Synchro Scheduler. That's something you should download. It's a free project management piece of software that is remarkable. It links all of the work back to what the students are doing for the competition. The team deliverables are pretty straightforward. The first and foremost thing that they do is a project plan. Now, the competition is open entry and open exit. There is no time requirement. So a student or a student team could enter the program, say they were going to start in February, or they wanted to start in May, or they wanted to start in October or November. It doesn't make any difference to us when they actually start the competition. Second is on their project plan. On our website, we have a lot of material available, some explanations as to how long we think a particular deliverable is going to take. So they can look at that and say, okay, well, I think I can complete this project in 8 weeks. Or another team says, well, we can complete this project in 12 weeks or in 10 weeks. It doesn't make any difference to us because the students know best their own schedules. With that being said, once they've made their project plan, we hold them accountable to that project plan. Okay? So they are in the driver's seat. The first big deliverable within the software is that they have to create a baseline energy audit. Now, what that does is it tells us a couple of things. One is that the students have learned the software at some level, they've gotten comfortable with it, and they can do the first energy audit. What we do is we check their numbers against what we believe are the correct numbers. We believe is the ballpark for an energy audit of the building that we've provided them. If they're off the mark, we contact them and say, okay, well, what questions can we answer? Or you should have clicked this button or made this selection in the menu versus what you did. So that allows us to get all of the students in line with the competition, with the software, and with the deliverable process. The next piece of that is now they get creative. Now they get to go through and generate a computer model and make the changes that they've imagined. Okay, and that's windows, walls, doors, floors, HVAC systems, lighting systems. They can change the roofing, change the building orientation. They can change the landscaping. We've had students put green roofs and grow crops on top of the gymnasium roof. Whatever they would like to do, the software facilitates them doing that. And again, all that is bound towards increasing the energy efficiency of that building. Then they conduct a second energy audit. How did the changes that they made impact the energy use of the building? And by the way, if they don't like those numbers that they got, they can go back and make more changes. It's up to them as to when they decide that they've gotten the results of the building as they expected to get them. So they've conducted that second energy audit, and along with that, now they start to add power generation capabilities to the campus. So they can add solar, they can add wind, they can add water, they can add biomass because the river is right there. The parking lots are large enough so they can do a fluid-based system, a conduit system for their HVAC systems and so forth. All that's possible during this part of the design phase. And then when they finished, they said, well, this is all good. We're pleased with our results. They write an impact report. They provide us with the highlights of their design and the design features and what they did that was imaginative or creative. And then they schedule a team presentation. Okay, the team presentations are all virtual. Matter of fact, the entire competition is virtual. But can you imagine your student from Denver or Salt Lake City or Chicago or St. Louis or Miami making a presentation to judges from any place on the world? So you have a judge in the UK, you have a judge in Japan, you have a judge in Australia, you have a judge in San Diego. We work out that kind of a schedule to make that happen. So the students say, okay, well, we'd like to schedule our presentation during this time frame, during this period. Can you make it happen? And we do. So following that verbal presentation, that part of the competition is done. And what we ask in this seventh deliverable is that your students make a presentation to your school officials about things that they could do on your campus. And what could they do to improve the energy efficiency of your campus? What could they do to provide power generation capabilities to your campus? And by the way, now that I've added power generation capabilities, what's my return on investment? They have to be able to calculate that. It's a business decision. So those are the 7 big deliverables. The student achievements are remarkable. I've had the opportunity to talk with parents, school administrators, counselors, and students about what they learned and how they've applied what they got out of the SMART competition. First, they loved having driven a project plan. They got started with it. They followed it through. They documented everything. Great experience for them. They learned a series of tools, Bentley software, the design software, that allows them to get very, very creative. And those tools are the same tools that are used by thousands of engineering professionals and architects all over the world. They've been able to use their imagination. They've created a computer fly around of their school, of their gymnasium if they wished, okay? And highlighted some of the things through a narrative in that video that they created. or just during their presentation about things that could be implemented at their school as well as inside their design. They've demonstrated and gained some very valuable 21st century skills. They've got teamwork. They've been able to outreach to other professionals. They've communicated effectively. They've solved a real problem. And last but not least, they've gotten some marketable skills. And it's great to hear from a parent or a student that says, you know, for my summer job, I went to work for an engineering company doing drafting and doing computer drawing, and I was being paid $20 an hour as an intern, as a high school student, but I wasn't flipping hamburgers. That was important. We recognize the schools and the teams for their outstanding work. The schools get STEM grants that can be used in the classroom to further what you're doing in the classroom. And we also provide individual awards for the students. Depending on the location and the timing, what's available, and if the students are available, they're invited to a Bentley or an IEEE sponsored conference to make a presentation to that conference audience. And the presentations that I've seen have been remarkable. What I'd like to do is invite you to visit the SMART competition site. The QR code will take you directly to the site. But stop and visit. Take a look at the materials, surf through what's there, and ask yourself a couple of questions. Can the content that is provided, coupled with your inspiration, excite the students? And that's really what it's all about. Can we get them thinking about those next generation issues? And second, will the program and the materials that we provide for you as an educator help you in your educational and classroom objectives? But ask yourself those two questions as you look through the SMART competition site, and feel free to contact me back. So my email address is here. I'm going to introduce two other people. Mark Schneider is a global director for Bentley Systems, and he has quite literally organized the staff and the user groups within Bentley globally to help us out and help the students out with the SMART competition. Everett Greenlee is a retired aerospace engineer, and he's responsible for tracking the student teams through the registration process and the communications process. Mark is a civil engineer and manages all of the technical piece. And again, I'm an electrical engineer, and between the three of us and the rest of the team that we lead, it's a remarkable experience. So please look forward to talking with you, and thank you very much for your time.